All right. So we had done till the fifth postulate, right?
Yes, ma'am.
Okay. Just a minute. Acha, did you all read the chapter? I asked you to read it.
Yes, ma'am.
Okay, good. Anyone else has read the chapter?
Ma'am, you said it in yesterday's class.
Not yesterday, but yes, in the previous class on Tuesday, I asked you guys to read the entire chapter because it's all written in the form of a story. Did you read it, Avni? Yes, Avni?
Ma'am, I just went through it and read it.
Acha, acha. Okay. Chalo, no problem. Just read it now. After we've completed the chapter, just read it. And I'm pretty sure you'll be able to understand the entire chapter. Okay. All right. So videos on, please.
One question, how much marks will tomorrow's test be?
That is going to be, I think, for around 30 marks. I'm not sure, but it will be for around 30 marks.
Ma'am,
Okay.
and the time?
1 hour.
Well,
Okay. So from 25 to 30 marks, 1 hour.
Okay, ma'am. Yeah.
Okay. So let's look at this question. So you have let's say a line. The question says that this is a line. Okay. This is point A. This is point B. This is point C. The question says that A, B, and C are 3 points on a line, and B lies between A and C. Then prove that AB plus BC gives you AC. This is something we have been using a lot in our triangles chapter, right? Then how? So this question is asking us to prove it through Euclid's theorems and Euclid's axioms and postulates. So how do we do this? We can say that AC, this AC, it coincides with, sorry, it coincides with, it coincides with what? It coincides with AB plus BC. This is AB plus BC. So we can see that AC coincides with AB plus BC. So see, if you had something like this, let's say you had something, this is A, this is B, and C is over here, okay? So in this case, this is your, or let's say somewhere over here. This is your AB, this is your BC. But AC does not coincide with AB plus BC.
Yeah.
Right? So in this case, AC will not be equal to AB plus BC. But only when it's given that the 3 points lie on the same line, then this statement will hold true. Not in this case. Is this clear? So by which axiom? Can someone tell me by which axiom does it say that when something coincides with something else, then they're two, both of them are equal?
Ma'am, the fourth one.
Yeah. So by Euclid's fourth axiom, they are equal. And you have to state the axiom, okay? I'm not writing it here, but you have to state the axiom. So things which coincide with each other are equal to each other. So therefore, since this coincides with this, therefore AC is equal to AB plus BC. Okay. All right. Then let's do another question. You have to prove that an equilateral triangle can be constructed on any given line segment. These are examples from NCERT itself. So if you want, you can refer to that.
Yes, ma'am.
So you have to prove that an equilateral triangle can be constructed on any given line segment. What does that mean? That given any length, you can construct an equilateral triangle. Yes. So let's see. Let's just take a random length. Let's take a random length. And now what we need to do is, you know how to construct an equilateral triangle. I guess you guys might have skipped that in your previous classes because that was deleted from the syllabus. So you take, let's say you have taken this as any radius, let's say 4 centimeters or whatever radius you have taken, doesn't matter. You take a compass, okay? You take a compass. The compass needle should be on this. Let's say this is A and B. The compass needle should be on A, and your pencil part of it should be on B. Okay. That means you have
Okay.
measured this length. Now with your A as center, don't remove the needle. Okay. With your A as center, make an arc and the same radius. With A as center, that means with keeping your needle on A and the same radius, meaning don't change the size of don't change the angle of the compass. Okay. Make an arc over here. Now same thing, take your B as center, meaning keep the needle now on B, but don't change the radius with the same radius. Radius of what? Radius of the compass. Okay. The same with the same length, the same angle of the compass, just make an arc over here. Okay. And now your needle
Yeah.
should be on B. So this point, now what you do is connect this point to A and connect this point to B. What you have here is an equilateral triangle. Okay.
Okay. Yeah.
Oh, now what you need to do is you need to show that this is what the triangle that you have constructed is equilateral. Let me first write the question. Show that an equilateral triangle can be constructed on any given line segment. Okay. For those of you who had missed the previous class of this chapter, I would suggest you go through the recording of that class. You can
Yeah.
ask for the link of the recordings from the number where the WhatsApp contact where you get the link of the class. Okay, they will give you the link of the recordings as well. So ask them the link
It's
and
also on the portal.
yeah, that's another way of accessing the recordings. So please go through that whenever you miss any class. Okay. Otherwise, it will be a little difficult for you to try to catch up what's going on. So now you
Yeah.
have to prove that this is the triangle that you have constructed is equilateral. So what can you do to prove this? Would anyone like to explain?
Ma'am, is there anything given?
What is given is that you have just constructed a triangle. That's all. and that this is a particular given length. That's it. See what we have done. See a compass. Why I kept saying with the same radius, same radius. Why? Because when you are using a compass, this is your needle and this is the pencil part of it. Okay. When you are making an arc over here, what is an arc? Arc is a part of a circle, right? So what are you doing? You're basically making a circle. Yes, you're not making the entire circle, but you're making a part of
Yeah,
the
yeah.
circle. So what we did was we made an arc over here. Let me just show you once again. We made an arc over here and we made an arc over here. So this arc is a part of this circle, right?
Yes.
The circle which has center A. I have made a very rough diagram. That's why it doesn't look like a circle, but it's a rough diagram. Okay. So this is a circle. Can someone please tell me? Acha, so remember that A is the radius of this circle. So
Yes.
sorry, A is the center of this circle with A as center and the same radius. What radius have we taken? We have taken this as the radius, right?
Yeah. So all of the sides are equal.
Because we had taken AB with the distance of AB. First, what we did, we measured the distance AB. We said, let's say it is equal to some number. Let's say R. Okay. Let's say R is a fixed number. It can be 3, it can be 4, it can be 10, anything. That's why I'm not using a particular number. I'm just saying R. R can be any number. So with that number, with that radius, we are making a circle around A. Now, obviously, whatever radius, whatever line segment you have like this, it's going to be the same radius, right? A line segment going from the center of the circle to the circumference of the circle. That is called the radius.
Yes.
Yeah.
So will postulate 3 will be applied here?
Postulate 3. What is the statement of postulate 3?
A circle can be drawn with any center and any radius.
Yeah. So yes, this we are applying this postulate also, and we are applying one more thing. So a circle can be drawn with any center and any radius. That is why we are drawing this circle over here. Okay, that is why we are allowed to draw the circle over here. Got it? Now, what we have is, I'm sorry, I just erased this. So what we have is, let's call this C, okay? So AC and AB are both radii. Radii is plural for radius. They are both radii of the same circle. Yes. And we know that if two radii are there of the same circle, that means they will be two radii of the same circle will be, there is a circle and you are drawing two radii of this circle, one over here and one over here. These both
Okay.
radii will be
Equal.
equal. Yes, they will be equal to each other. Radii of the same circle, therefore they are equal.
Okay.
Since AB and AC are radii of the same circle, therefore they are equal. Any doubt in this?
No, ma'am.
Ma'am.
Okay. Therefore they are equal. So now since they are equal, and one more thing, similarly we can say that we can draw a circle around B. We can draw a circle around B as well. And same thing will happen Similarly, A, no, sorry. Now, can you tell me about the circle drawn around B? AB and BC are radii of this circle, right?
Yes, ma'am.
AB and BC are radii of the same circle, the blue one, the blue circle. So therefore they are equal again. Therefore AB equals BC. Now from these two things, from 1 and 2, we have AB equals AC and we have AB equals BC. This is from 1 and this is from 2. So which axiom of Euclid says that things that are equal to the same thing are equal to each other?
Axiom 4.
4.
No.
No,
Axiom
axiom
1,
4
1,
talks
1.
about the first axiom.
Yeah.
Yes.
So this says that AB is equal to AC, which is equal to BC. Okay.
Yes, ma'am.
Okay.
So now since the three sides are equal, therefore triangle ABC is an equilateral triangle. Okay.
Okay.
All right. Next, there's a theorem.
Ma'am, 1 minute, can you go back?
Okay.
I'm done.
Okay. So there's a theorem that, and we know this, but we are gonna now prove it by Euclid's axioms, okay, and postulates that two distinct lines, distinct means different, distinct means different, okay, two
Yeah.
distinct lines have only one point common between them, or in other words, cannot have more than one point common in common. Okay. Acha, this says this theorem says two distinct lines cannot have more than one point in common. Can they have less than one point in common?
No.
Maybe.
No.
No.
Oh, yeah. They can.
For example,
If like A is a line and B is a line and they do not parallel lines.
parallel lines. Yes. So that is why over here we have cannot have more than one point in common. So they can have one point in common and they can have 0 points in common, but they cannot have more than one point. Okay. So two distinct lines
Yes.
cannot have more than one point in common. Why? Because Euclid's, okay, who will tell me which axiom of Euclid says that uh, there is, if there is a line, okay, just give me a second. Yes, apologies. I was being called. Yeah. Okay. So, which Euclid's postulate says that from one line, or rather, yeah, from two different points, you can draw only one line. Which axiom says that? Sorry, which postulate says that? Is my question clear? Should I repeat my question?
Yes, ma'am.
See, over here, what do we have to show? We have to show that two distinct lines, two different lines. Let's just draw it and see. Let's say there are two different lines. What are the possibilities we can have? They can either be parallel, okay? They can either be parallel or they can be intersecting. Is there a third possibility? Is there a third possibility? Can anyone think of a third possibility? Yes or no?
Um, no.
No, right? So there is no third possibility. There's only two possibilities
Yeah, just
about
two.
when it comes to two lines. They can either be parallel or they can be intersecting. Now, this theorem says that they cannot intersect in more than one point. Either they will have no point in common, like in parallel lines, either they will have no point in common, or they will have only one point in common. There's no other option. You cannot say, oh, I have found two lines which two intersecting lines which have points in common or 2 points in common. Why? Because as we can see geometrically, this is how we can represent that, right? We cannot, let's say you want to intersect them at 2 points. Is this possible that
No,
a
no.
line goes through this and then another line goes through this also and this also? Then it's not a straight line, right? See, look at both of them. They are intersecting, but this is not a straight line. This is something else. This is a curve. Yes? So this isn't possible. Now, how do we prove this? How do we prove this using Euclid's postulates? So you see, let's assume, let's just say as a hype, as a assumption that okay, someone is saying that there can be 2 points in common. Then okay, fine. Let there be two different points in common between two lines. Okay. Then what will happen? Let's say this is a point P and this is a point Q. They are two different lines. Sorry, they are two different points. And we are saying that both the lines pass through both the points. But this axiom, the the first postulate, sorry, go through that again. Where did it go? One sec. Yeah. The first postulate, it says that only one line can pass through two distinct points. Look here. Only one line can pass through two distinct points. So if you have these two distinct points, you can draw only one such line which passes through both of them. So that's why this assumption of ours, it fails. So we can conclude that two different lines, two distinct lines can only intersect in one common point, or they won't intersect at all maybe, but they cannot have more than one point in common. Is this clear?
Yes, ma'am.
So for this, you need to use postulate 1. Okay, you need to use postulate 1 to disprove this, to say that if you take 2 points in common, then this will fail because of the first postulate. Okay. All right. Uh, Avni, yeah. So why haven't you done the homework? Because you said you have received the homework PDF, right? Yes, Avni. Are you there? Acha. Anyone else has tried the homework? Okay, Priyashita, do one thing. Send me a message.
Yeah.
I shared my number, right?
Mm-hmm.
Do you
Yeah.
have it?
Okay.
Send me a
Yes, ma'am,
message
I do.
so that I can send you the PDF of the homework.
Okay. Okay. Yeah.
Okay? All right. Let's do the first exercise then. Okay, now one by one. First of all, Riaz, are you there? Please unmute or switch on your video if you're there. Okay, Abdul Jabbar, are you there?
Yes, ma'am.
Okay, Zen. Zen, are you there? Unmute or switch on your video if you're there. Okay, Zen is also not there. Munir.
Yes, ma'am.
Okay, Munir is also there. Abdul Rahman.
Yes.
Okay, fine. Now I will ask you these questions one by one. Okay.
Okay.
Only you have to tell whether this statement is true or false.
Okay.
Only one line can pass through a single point. Zen. Okay, he left. Abdul Rahman.
Yes.
Yes. Can you please tell me whether the statement is true or false? What do you think? This statement.
False.
Very good. What should the answer be?
Uh,
How many lines can pass through a single point? You have a
uh,
single point over here. How many lines do you think can pass through this?
wait.
Yeah, it's okay. Say it.
Two
Two.
or
Okay. Huh?
two. Okay.
Two. Not more than two?
Oh, wait. There is four.
Four. Not five?
Okay. Five.
Why not six then?
Uh, I think it's only total.
Yes?
Total is five.
So only five lines can pass through a single point, not more than five lines.
Oh. Oh, I thought those. Okay, so.
There's a single point. How many lines do you think can pass
Oh,
through this?
no, I thought differently. I thought like one straight line through is like I thought the both lines count as one.
Acha, now tell me, how many lines do you think can pass through a single point, Abdur Rahman?
Seven. Wait,
Seven. Okay, why not eight?
10.
10. Why not 20?
Haha. Okay, how about infinite?
Yes, exactly. The answer is infinite. Okay. Through one single point, you will have infinite number of lines. Infinite number of lines. Is this clear?
Ma'am, ma'am,
Yes.
Yes, Abdur Rahman. What are you saying?
I just like jokingly say that it was actually right.
Yeah, it is right. And you said it jokingly because there is no other answer. Okay, because you were like, okay, what? Not even 2, not even 10, not even 200. Then you know what? I'm just gonna say the biggest thing that I know of, and that is infinite. And that is how we arrive at this actually. Okay, that is the reasoning that we follow. So, okay. So, next statement. There are an infinite number of lines which pass through two distinct points. Abdul Jabbar,
False, ma'am.
false. So this is also false. This is also false. Okay, what will be the true statement for this?
Only one.
Only one line. Okay, only one line, just like we saw over here, that through two distinct points, only one line can pass. Okay, all right. The third one, a terminated line can be produced indefinitely on both the sides. Avni,
Yes, ma'am.
yeah, true or false?
False.
Okay, then what will be the true version of this? How will we correct this?
Line line segment can be produced indefinitely on on both the sides.
Yeah. See, Avni, according to Euclid, he used the word terminated line. The same thing, we call it a line segment. Okay. So we
Yeah.
say line segment. According
Okay.
to him, that is a terminated line. Same thing. Just different words, but same thing. Terminated line means line segment only. So now tell me, is this true or false?
It is true.
Very good. It is true. Next one. If two circles are equal, then their radii are equal. Preshita,
Yes, ma'am. That's true.
true. Okay. Who is left now? Okay. Okay, so they've given a figure. There's a line segment AB, then there's another line segment PQ, and then there's another line segment XY. They are saying if AB is equal to PQ and PQ is equal to XY, then AB is equal to XY. Is this true or false, Zen? Zen, is this true or false? I can't hear you. Okay, Munir. Munir. Acha, Avni, yes? You want to say something?
Ma'am, it is true.
Acha, okay, it is true. By which axiom is it true? Who will tell me which axiom is it true? By which axiom? This question is open to anyone.
Ma'am, the first axiom.
The first axiom. This is true by the first axiom. Okay. The second question is there, but they won't really ask you such questions. You can uh, do this question on your own. Okay. This question is very simple actually. It's just asking for definitions. It's given in the textbook. Okay. The definition of parallel lines. Okay. Or let's do one thing. Let's just do the second question also. Fine. So that there's no confusion left. The first one is parallel lines. So they are asking you to define parallel lines. How can you define parallel lines?
Two lines
I
which do not intersect each other.
Very good. Two lines which never intersect, or you can say one thing. You can say two lines which never intersect, and you can say two lines which have no points in common. Yes?
Yes.
Okay, now second, perpendicular lines.
Intersect each other.
Someone said something.
When they intersect each other at a point.
They intersect each other at what?
When a line intersects another line at a point.
So they become perpendicular.
They form a 90-degree.
They form a 90 degree. So first you have to tell what a 90 degree is. Right? That's what a definition.
Exactly.
That's when a definition becomes acceptable.
Yeah.
Hmm.
When two right angles are formed.
Very good. Not exactly two. There are four right angles that are formed, right? So see, when you have two lines like this, 1, 2, 3, 4. But have we defined a right angle yet? We haven't
Yeah.
defined the right angle, right?
Yeah.
Hmm. What all? Okay. So has Euclid defined a right angle? No,
No,
he
mom, he
hasn't.
has.
He has just defined a point, line, straight line, surface.
Yeah.
Yes, plane surface.
So,
Okay. So if you want to talk about perpendicular lines, yes, you can say that two intersecting lines that form a right angle, or instead of saying right angle, you can also say 90 degrees. Okay. Then line segment, how will you say line segment? How will you define line segment? A part of a line or a terminated line? Yes?
yes.
Yeah, a part of a line or a segment of a line. Okay, then radius of a circle and square. See, these are things that won't really be asked in your exam. Do one thing, take this as homework because we have to complete this chapter, and then we have to, after this, we have your backup class as well. Okay. So radius of a circle and square, try these on your own. Fine. Third question also you can do by yourself. Please try it. If you're not able to do it, we will discuss it in the class in the next class. Okay. Fourth one, this kind of question we have already done before. A point C lies between two points A and B. This is A, this is B. Point C lies between them in such a way that AC is equal to BC. They are saying prove that AC equals half of AB. Yes, how will you prove this? Using Euclid's axioms. See, AC equals,
Fifth, ma'am, fifth
yes,
axiom.
fifth axiom. What does the fifth axiom say?
The whole is greater than the part.
It is greater than the part, right? But we don't have the we don't have to prove that it's greater. You have to prove that AC, this one, is half of that. Are you getting it? See, if C is over here, let's say this. So AD is a part of AB. So yes, obviously the whole is greater than the part, but over here it's not exactly half of it, right? So you have to prove that this portion is half of the bigger portion if AC equals BC.
Ma'am, then axiom 7.
What does that axiom say?
Things which are half of the same things are equal to one another.
See, this axiom won't apply here. Let's see how. Okay, let's see what axiom we're going to use. Which axiom we're going to use. See, AC is equal to BC, that is given to us. Now you use the axiom which says that, okay, AC plus AC equals BC plus AC. Which axiom is this? Equals are added to equals. Then the wholes are equal. Yes? Equals are added to equals. AC and AC. We are adding AC on both the sides because these two things are equal. So we are adding the same thing to both the things, both the equal things. So that's also going to be equal. Now, what is AC plus AC? Twice of AC. Yes. And what is BC plus AC? Look at this. Very good. So BC plus AC is AB. So this gives you, okay. And over here also you use the reason, the same reason which we used over here, I think. We used it over here. Where did it go? This one. If AB plus BC, you had to show it is equal to AC. Yes, that the same thing we're going to do over here. That the fifth axiom, I think, or the fourth one, that BC plus AC coincides with AB. So it will be equal to AB. है ना? Therefore, BC plus AC is equal to AB. Fine. Any doubts still here? Now over here you can just AC is equal to half of AB. Fine.
Yeah.
So the next question, you have to prove that every line segment has one and only one midpoint. What is the meaning of one and only one? Why can't we just say one midpoint? The reason you have such statements in math is because one and only one, this, the first thing, it has one midpoint means that it has one midpoint. That's it. Okay. You're not restricting it to one. It has a midpoint. Or if I say, for example, I have a bag. I have one bag. I have a bag, same thing. But if I say I have only one bag, then it's different. If I say I have one bag, that means I can have more than one bag as well. I can have one bag or more than that. Yes. But if I say I have only one bag, then that means I either have one bag or less than that, not more than that. So when you say one and only one, it means not less than one, not more than one, exactly one. Okay. This is what one and only one means. Anyway, so that is just some mathematical statements. You have to prove that every line segment has only one midpoint. Yes. Any ideas? Okay, let me tell you something about math. Is that when you have to prove that something is unique, remember in math, when you have to prove that something is unique, in that case, try taking an opposite assumption. Just like we did over here, we had to prove that two distinct lines cannot have more than one point in common. In the sense, we wanted to show that this point of intersection is unique, meaning that there's only one point of intersection. So what did we do to prove that? We said, okay, let's say there are 2 points of intersection, then let's see what happens. Okay. So this is called proving through contradicting. We are going to contradict our assumption. We made an assumption that there are 2 points of intersection, and we contradicted that assumption. So now we're going to do the same thing. We are going to say assumption. Let AB be a line segment which has two midpoints. Let's say C and D. Okay, let's say there are two midpoints. And that means if they are both midpoints, then that means, okay, so over here we had a midpoint, right? So that means AC is half of AB. If C is a midpoint, then AC is half of the entire length, right?
Yeah.
So that means AC is half of AB, and also AD is also half of AB because D is also a midpoint. Now we have seen that things that are halves of equal things are equal. Which axiom do we get this from? Things that are halves of the same thing are equal.
Axiom 7.
7, yes. So by the seventh axiom, and you have to state that axiom, don't forget. By axiom 7, and write the statement over here. AC is equal to AD. And now, since AC is equal to AD, that means they are both coinciding, right? That means C and D are the same point. Okay. So therefore, there is a unique midpoint. That means the midpoint is just one. Okay. All right. Let's move to the next question. This is also something you can do by yourself. If so, this is a figure. This is A, D, B, C. They're saying if AC is equal to BD. AC is equal to BD. You have to prove that AB is equal to CD. Given AC is equal to BD, to show that AB is equal to CD. Which axiom do you think you have to use here? Which axiom do you think you have to use here?
I'm in the sixth question, right?
Yeah. I have written the question over here as well, that AC equals BD. So you have to prove that AB equals CD. Okay, let's just do it over here. Okay. See, I'm going to do it very quickly. So stop me if you're not able to understand anything. So it's given that AC is equal to BD. Now AC can be written as AB plus BC, and BD can be written as BC plus CD. Since again the same thing, it coincides. AB plus BC coincides with AC, and this plus this coincides with BD. Anyway, so now we have seen that if you subtract the same thing, then the remainders are equal. Yes, if you subtract the same thing from two equal things, then the remainders are equal. We have seen that. Which axiom is it, Avni?
Ma'am, the second one.
Is it the second axiom? Acha, no, it's the third axiom.
Third one.
Yeah. Equals are subtracted from equals. Then the remainders are equal.
All right.
Yeah. Over here, what is the remainder? What is remaining? AB equals BC. Sorry, CD. So you have removed this BC and BC. So AB equals CD. Hence proof. Seventh one, why is axiom 5 in the list of Euclid's axioms considered a universal truth? Well, it's considered a universal truth because it's true everywhere. It doesn't matter whether it's a plane surface you're talking about, whatever surface it is you're talking about, it is true everywhere. Okay, that's why it's considered a universal truth. Any doubts from this chapter?
No, ma'am.
Okay, let me just okay. Aksha. Okay. Preshita, I believe the PDF has been sent to you, so please complete the homework and send to me, okay? And the rest
Okay,
of
I'll
you
just
as well.
recheck. Yeah.
Yeah. So rest of you also, please submit your homework. Why the reason I focus so much on homework is because unless and until you study on your own, you try to solve some questions on your own, math is something that you won't get, okay? Unless you try to do it on your own. So please do the questions. Okay. Now, so let's do one thing. I will share it. Do you want me to share the questions on the screen and you guys can go through it and let me know if there's something you find difficult in the questions, in the homework questions? Or do you think you can do it on your own? All of you received the questions, right?
Yes, ma'am, we received it.
Okay. So shall we move on to the backup class of number systems? Are you all ready for that? What happened?
Yes, ma'am.
Yeah, we won't have a very long class, don't worry. Okay, let's do one thing. Let's take a quick 5-minute break, but only 5 minutes. Don't extend it to 7 minutes or 10 minutes, okay?
Yeah.
Let's take a quick 5 minutes break and come back, and then we will continue with our backup class of number systems. Okay?